In this video, I would like to derive a generic formula for this type of integral, the integral of the inverse function. Now, I need to be clear exactly what I mean by this. So we assume that we have we know a function f, f of x, and f of x is a function that is integrable, and so is its inverse. Of course, f needs to be invertible and possess an inverse at least in some interval. And in addition, we will assume that we know the primitive of f, that is the antiderivative, and we know how to integrate f, basically, in, say, elementary functions. So we know that the antiderivative of f, will write it as capital F of x plus a constant, and now we would like to express this integral of the inverse of f in terms of f and capital F, and maybe f inverse. So how would we do it? Well, let's start. So we want to compute the integral of f inverse of x dx, right? So here it seems quite natural to substitute for x f of t, because, right, why is it natural? Because, well, when I plug x in here, I plug in f of t, so it's f inverse of f, it's just going to be t. But let's see whether we can proceed here. So dx is going to be f prime of t dt. And then the integral becomes, so it becomes just as I said, so when I plug in instead of x, f of t, so it's going to be f inverse of f of t, it's just going to be t. And here we'll basically write f prime of t dt. Now note that this is quite natural of taking by parts, because we have a function, and here it's like, the pattern u v prime. So, and it's quite natural to take this function as u and this as v prime. This is our perfect setup, right? Because in the next step, we're going to differentiate u, and it's basically going to disappear, right? The differentiation will yield 1, and 1 will be multiplied by v. So it's great. So this t is going to disappear, and now basically, so we have a two-step evaluation here. So we've made the right substitution, and now we're taking the integral by parts. And so let's see. So it's going to be uv. So of course u is t, and then the integral, of course, if this is v prime, then v is going to be f of t. So it's going to be t f of t, and then minus the integral of u prime, which is 1, as we said, and times v, and v is f of t dt. And now here's the nice thing, because we assume that we know capital F, the antiderivative of f. So this becomes t f of t minus capital F of t, and of course, not to forget, plus a constant. So the last step would be just to express this formula in terms of x. So let me rewrite this again. So we have the integral of f inverse of x dx is, okay, so we know that f of t is just x, so I'll write it as x, and of course t is f inverse of x. So we got this part covered, and minus capital F, and of course t is f inverse of x, and plus a constant, and this is our generic formula that we wanted to derive. Now let us see an example of how this formula can be applied. It's quite generic, so it can be applied in quite general circumstances, but let's try a simple example of something that we already know. So let's choose the arcsin of x dx. So this, will call this our f inverse of x, and of course f of x is just the sine of x. So this function, of course, we know it's integral. It can be taken by parts, so we can think of it as being 1 times the arcsin of x, and then this will be u, and this is going to be this will choose this as u and this as v prime, and it can be evaluated by parts, but and will yield the same results as we get here. But this formula gives the result quicker. So let's see. So capital F of x is of course going to be, so the integral of sine is minus the cosine of x, and we'll leave it as that without the constant. We'll add the constant later. So let's see. So using this formula, we get that this is x arcsine of x, and now minus capital F. So capital F is minus the cosine, and so we have the minus from here, so it's going to be plus the cosine of arc sine of x plus a constant, that would be a sufficient answer, but we can take it one step further. So let me just rewrite it one last time. So arcsin of x dx equals, of course, x arcsin of x. And here, so we can write cosine as the square root of 1 minus sine squared of, and what we have here is the arcsin of x. So, and plus a constant, and now of course sine of arcsin is just x. So finally we get that the well-known formula that it is x arcsin of x plus the square root of 1 minus x squared plus a constant. Thank you for watching, and don't forget to subscribe and hit the bell button not to miss future uploads. Thank you.